Good morning, developers. If you're new to the channel, my name is Rob, and it is CS Thursday, the day that we lift up the hood and we try and figure out what's going on under there. How do things work? And today, that brings us to the data structure linked list. Data structures, if you're new to computer science, it's a little bit different connotation than a data type. Data types sometimes are data structures, but a data type is something that's built into the language, that the language has already defined the paradigm for a number, for a string. This is how the memory gets organized. These are the methods you have available. You might be able to add some onto it, but those decisions are already made and you can use them. And if you're new, you might be more than happy to end there. But with a linked list, a data structure is more of a concept. And linked lists, at least, I have never worked in a language where they're natively supported, so you have to create it yourself. And the truth is, in JavaScript and in Python, which there's a good chance that that's the type of developer you are, arrays or lists are already kind of like linked lists. At least they're far more like linked lists than they would be what would be a traditional array in C. But they're still worth learning about because it has to do with how data is organized. It's really helpful, again, to look at how things work underneath the hood. Let's say we had a bunch of random numbers and we want to put them into order, okay? We'll say that we've got them in order and they're 4, 6, and 9, okay? This looks like something we would keep in an array. We want this thing followed by this thing followed by this thing. It's discrete, index 0, index 1, index 2. That makes perfect sense. That's how we normally operate and do things. Well, with a linked list, instead of being an indice or an element, I guess, in the array, it would be a node, and a node has two parts. It has the value itself, and then it has a pointer to the next thing in the list. So what you do is this first element, instead of going to the next element, and I'll show you how arrays would traditionally do that in a second, you would tell it, hey, this is the next element in the list. This one would point to the next element in the list, and this one would point to null because it's the last element. This top thing is known as head. That's how we get to the first thing is it doesn't have anything pointing at it, okay? This is essentially a linked list. You now know what a linked list is. The question is, why would you ever use this instead of using your traditional array? Well, what if you wanted to put in the number 7, okay? How do we do that? Well, you have a splice method in JavaScript, and depending on the language, there might be some way to do that. But in a linked list, all we have to do is get rid of this pointer and point to this thing instead. This thing will have its own pointer, and it will point there. It only takes one operation, I guess two operations. We change that pointer, and then we add this node. But it only takes really one step to completely alter the entire list. In an array, in programming languages like Java and C C#, they use contiguous blocks of memory, meaning this thing is going to be in this spot, this one's going to be in this spot, and so on. So we have, I'm going to totally make this up, but let's say this was this was block 1 of memory, this is block 2, 3, 4, 5, and so on. It has to be done this way because, it doesn't have to be, but one of the reasons why it's done this way is so that when an element is indexed, it's really, really fast. Because when you go to memory to find the next element, it's always going to be the next memory register or the next block that is available. So this makes arrays in C, Java, and so on really, really fast. But if you're gonna do an operation like this, we have to potentially create an entirely new block of memory to mutate it, etc. There's a whole bunch of stuff that goes into it, and that might have a big O notation of n because we have to go all the way through the list. With a linked list in any language, as I said, these they're standalone little elements. So we have a thing here, we have a node here, we have a node here, and a node here. Maybe this is block 6. Maybe this is block 93. Maybe this is block 407. And this is block 1. It doesn't make any difference. They can be apportioned wherever it is convenient for the computer to put them, as opposed to here, where it's going to put them in order, and they can simply point to each other. And the memory management becomes so much more efficient. And as I said, inserting and deleting things becomes so much more efficient as well. In JavaScript and Python, as I said, this is more how it works under the hood. You don't know it because you don't ever have to deal with it. You just run push or pop or append or whatever. In C and in Java, the lists or the arrays have a fixed length. You have to create a new thing in C that has the correct length for your new array. And so linked lists create a really powerful data structure that essentially has been implemented in JavaScript and Python already, where things can be managed dynamically. You can add new elements, you can remove elements, you can really quickly do an insert or delete, and it takes almost no time to accomplish. The implementation process is pretty simple in most languages. You would have essentially two different types of objects, a class, whatever you want to call it. You would have the node itself, and the node would have two different pieces of data. It would have where the next one is and the value of this node, and then you would have the entire linked list. And the linked list would have these various methods, the insert, the delete, all of that stuff, the update. And it would contain nodes. So you'd have an object, your linked list, which would contain node objects, and you would point around. Okay, that is pretty much the simplest version of how linked list works without implementing. I can drop an implementation in the description if that's interesting. But this is really helpful to know what's going on under the hood, how things are being moved around, and how much more efficient in memory you can be with an array if you want to be really fast and go to the next thing in memory. Again, that's why C is really fast. But something like this can make a huge difference in the right scenario where you need a dynamic sized element. You want to be able to move around quickly. You want to be as efficient as possible with your memory usage and so on. Thanks so much for watching. I will see you next time on CS Thursday.